I will say a few basic ideas about the identity and blockchain. So, blockchain as a distributed database in in an environment which is public, typically public, is may be considered as an analog of a public square where everything is seen and recorded, and in the same time it can be used by private identities in a very similar way like public notary. So it is very good place where you can keep uh, keep data which uniquely uh, talk about certain um, um, certain features of people or items in the real world. So we can take, say, works of art. You can consider people. You can consider public organizations, and each of them will have certain features which will be recorded and confirmed on the blockchain, and this can be used for various purposes. So, first notion is the notion of sovereign identity. It's a new notion which really came with the blockchain. Namely, what is identity of a person? Identity of a person, well, there are various identities. You have your name, you have your birthday, you have various features, which may be formally written somewhere in some documents, but are also part of your presentation to the external world, and part of how other people, documents and so on, perceive you. So they perceive you even as you can have various avatars. You can be in the same time a worker in a factory and a member of a sport club, and you are perceived in sport club as a soccer player with such and such features, and that's part of your identity. And sometimes some of these are formalized, and you have some document that you are, say, a certified master of plumbing or whatever. And how to now many of these certifications are under control of various authorities in the real world, of police, of interior ministry department, and so on. Let's take some hypothetical situation when you use your identity. So, for example, you want to take your child to a school. So take your child, and by the hand you come to the school, and they ask you over there who you are and so on, and you have to present documents of your child. Now, a person in the school may need only part of documentation of your child. Say they want to know the age of a child. They want to know where do you live, whether you qualify for a certain school, and so on. maybe what is the education before that. But they do not need to know whether the child is sick or not. So if we would have some sort of a long record, long record, which is a kind of a formal record of your identity, then it would be nice that you can simply take once for all your purposes, whether you go to a doctor to see a doctor, whether you buy a cigarette and you want to prove your age to buy a cigarette, or you want to enter a school or something, and that you have one kind of identity, kind of record of identity, which is very comprehensive and which is certified in a certain way. We will talk about certification separately. So some of these items are filled by certain authorities. Say when you are born, then you get birth certificate. So birth certificate, maybe you have a copy of it, maybe somebody signed the electronic document, etc. You have this document with all the certifications, and you want to show just part of this to the school official, not the private part, which they do not need, and you should better keep not from them seeing it. Then what you can do, you can have the whole certificate in encrypted form, and have some sort of hierarchy of keys or whatever system, which enables you to which enables some to decrypt part of this information. So the school official may have authority to decrypt some of this, or maybe doesn't have authority, and you simply release part of this information, that you simply give key, or you somehow maybe you generate a key which will decrypt just part of this document, just part which is relevant for this school. That's called self-sovereign identity. Sovereign identity. So self-sovereign identity means that a person is in control who can reach what. And then this control may mean that in a single visit to a school, you release some information on, or that you release it once for all for some classes of situations, or some classes of other parties. So say you can say, I give my education information to all educational institutions, whichever wants to look in this data. So there is your key, which you generate, which will allow decryption of some part. But even then, you may ask for additional authority that say a school official in addition has to prove that it's really a school official. So not only that you come to the school, but school official has to show its own part of identity in a sense, or its own keys, which will say, okay, I can see that, provided you also gave me your part of the key, or maybe just one of the two. So there are many scenarios, but in any case, you are in control of your own identity, and you can add new records to it And these records, you want that they are certificates by some issuer. So any part of identity, there is an issuer of identity, or issuer of or issuer of certificate of identity is better. Certificate. So in general, when you have certificates of anything, then there is a certified party and or owner of certification. There is some sort of owner. And there is an issuer of certificate. So sometimes that can be one and the same person. I mean, you can sometimes say, I choose my something. You can choose some parts of your identity yourself, for example. And then you are your own, then you are both an issuer and owner. But usually these are two different parties. So somebody gives you a school diploma, for example. And you own this diploma, but on the diploma there is some sort of there are some signatures, there are some dates, and so on, and maybe there is some database where things can be checked. You know, it can be a forgery. So how do you know that it's forgery? That's not a forgery. You put this encrypted record on the blockchain, either that it's literally on the blockchain, that it's written on the blockchain, or that on the blockchain you have simply a hash, or maybe several hashes of the parts of the documents, which are kept somewhere outside of the blockchain, and sometimes can be accessed by anybody, by any computer, because these are anyway encrypted, so it's okay. Or maybe that blockchain does not have this information. Only you have this information. That's also a possibility, that only a person can have a record, the full record, and on blockchain there is a hash. Then when you come to the school, then in order for them to be sure that that's yours, then can check some hashes, some information. For example, they can be hashes of some parts of some certificates and so on from this on the blockchain, and so that they can check on the blockchain whether what you show them is really correct. Or maybe, or a different situation, a school, maybe even more relevant, say you have your own record. You don't need to put any hashes on the blockchain. Your own record is just your own record. You have some computer file which you always carry with yourself. However, the issuer of the identity, of some part of the identity, say the school which issues a diploma, has on the blockchain the data of the hashes of all records of all diplomas which they issued. So when you bring the diploma, and diploma looks like it is from Paramount College. Paramount College. I think it doesn't exist, but I'm making it up. Paramount College is having some list of hashes of diplomas which they issued. They don't put the names of people. That would be revealing some sort of information which can be private. They have some hashes of it. Now you bring a file which has one of these hashes. So in a school they check the information on the blockchain, and they see, this certificate is really issued by Paramount College. And then they'll just look at your record. So you have a computer record, it's just computer file. It can be copied, it can be multiplied, you know. Is the information correct? Well, the entire document has its own hash. Nothing can be changed. If you change one single letter, the hash changes so drastically that nothing can be recognized. So there is no possibility in practice that you change this document. You have some record, and you have to show this record in its entirety. The computer checks its hash, compares the hash, the computer of the official who looks at your record, looks at the hash on the blockchain, compares, and if the hash obtained from your record and the hash from here match, then they trust this particular document. So this is extremely useful mechanism. On the other hand, there are some long-term problems with any kind of cryptography. You see, for example, if you have your data cryptographically insured, somebody can reach maybe you have at home somewhere written your cryptographic keys. Somebody finds your record, copies it, and can decrypt your private information. Or somebody can try many keys and reveal part by part your key by some complicated procedure. Sometimes you expose parts of the key by various users of the key, and at the end they get your key after a lot of effort and maybe many years. So usually various certificates, various cryptographic certificates, say of the internet servers, of your identity which you use in the bank and so on, have to be updated. Sometimes very often. Sometimes, say, laws require certain certificates to use in the banks and so on to be changed every 3 months. And sometimes, is the general public educated enough and has the resources to keep this? And what happens if the key is lost or the key is compromised? So on the blockchain, usually by default you have no mechanisms how to change if somebody is owner of an account. Once somebody else gets this cryptographic key, you cannot change anything. So it's good to change to another account and to move periodically to another account and so on. And on the blockchain, you keep the record, so that if somebody has somewhere information that it has been generated by this first account, then you know that that now this is controlled by this third account. But what if this external information is generated by this first key much later, and we pretend that it's generated before? That means that external place where the identity is kept should also keep some sort of a record of its history. So say if I am somebody who used some certificate, so somebody came with a certificate on 10th of January, and using this certificate made some transaction with me, say bought a house and used certain identity with it, and I changed my cryptographic key in April. I changed it because this first key might be compromised after several months. And now somewhere later in, say, May, somebody comes and says, I sent this to this guy, but this guy, this first identity cannot be anymore confirmed and so on. It can be confirmed only by this later guy. But you see, this later guy says, no, I did not sign that. I did not sign that. Somebody else signed that. How to resolve this conflict? Because maybe this key was compromised after April, written after that. So what I can do, I can put the hash of this transaction signed by both parties, also on blockchain, maybe not the same blockchain. So I put it on the blockchain, this hash. And then I know that the record of using this identity has also been before one cryptographic feature of this identity has been changed. So in long term, you do not only have to worry about whether the identity is correct, but also about updating identity. And if the identity has been updated for whatever reason, which may be sometimes even some sort of recovery procedure or something like that, say the key has been possibly compromised and we recover so quickly that nothing can be used before this recovery date, but maybe it can be used after that recovery date. We see on the blockchain there is nothing written yet, and if we change in this moment, we are sure that everything is correct. But before that, we have to have a procedure that we are putting hash here. We do not trust anything. Nothing is finalized until we put the hash here. Of course, now this finalization question is a very difficult question. What if we signed the contract, etc., and putting the hash did not succeed? If both parties are present here at the place when they are doing that, then they can control each other and everything is correct. But if this is done by, if you put the responsibility of putting the hash to one of the parties who is authorized to that, that party doesn't do, can we undo the whole thing? If we put that the contract is only, or our transaction is only then finalized when we put finalization on the blockchain. So can we undo the previous step? You see, there's always additional confirmation, and this additional confirmation, if it doesn't happen, then this is the problem when you do things in sequence with finalization of contracts. This is unsolvable problem. So we usually make some assumptions. We make assumptions, say that the internet is available, that this can be done, that you have some mechanism that the money can be returned or whatever within such and such amount of time. So to some extent you can mitigate this problem, but in any case there is always problem with the finalization, of transaction, because one of the parties may simply not see this last step, can simply not having available access to the internet or whatever, and the last step happens. The whole world thinks that everything is correct, but one party is simply not present to say it's wrong. If you want this party to confirm, then this party is last. So the other party is now again vulnerable. So whoever step you accept as the last one, the other part, you're not sure whether the last party received the information that this last confirmation has been done. Of course, in practice, most of the time you make sure that such things do not happen, that there is enough time, that there is enough accessibility, so that it's some sort of equivalence of that the contracts are usually done in person. So if you have both parties at the table, then if there is disagreement, simply it practically never happens that somebody signs and before the document is read, or that one party signed and another takes the paper out and signs and does not allow another party to simply when both parties are present, you cannot really cheat. I mean, you can imagine that you steal the paper signed up by only one person, and the other person, and then take the paper away, and then the person will never know whether that another person signed later and used this document, because if the document is signed only by one person and is in possession of another person who is not present there, then some cheating can happen later, because that person can simply add the signature later, but you never know whether this person signed or not. So such stealing of paper will not happen if you are in person, but so some legislatures, some jurisdictions require that certain level of contracts have to be done by people in person. But if you do complicated procedures online and so on, or you are using some data representing some parties or part of the identity from outside, then such things can be messed up. Okay. Another issue is so-called question of quantum computing. Namely, most of the security on the internet is now done by public key cryptography based on number theory, and virtually if you use quantum computers, that's a new generation of devices, there are algorithms which could compromise this cryptography. So we should change our cryptography to a new kinds of cryptography which would not suffer from this problem, and that's called post-quantum cryptography. Cryptography. There is so-called lattice algorithms and so on. But unfortunately, it's less known and it's less routine, and people use programs which already use various procedures with standard cryptography. So one should write updated versions of these procedures, new software, and so on. And most of blockchains are based on the old-fashioned cryptography based on number theory. So this is one of the issues which happen if you are planning a system for a very long time. If you're planning a system for a very long time, it should not be based on present cryptography, or should have its mechanisms how to change later. You see, systems have to be much more flexible. If you look, say at smart contracts, one of the features of smart contracts is that you kind of put all the procedures in advance, all the future procedures. That's a problem, because in real contracts you can never predict all the scenarios, and there are some situations which you do not predict in advance. So in such situations there has to be some resolution of conflicts and so on. So resolution of so when you do smart contracts, then you have a hierarchy of contracts. You have some basic contracts which do basic operations, but you also have some higher level contracts which control the original, the basic level contracts, in the sense that they sometimes can change their states if certain conditions are made. So usually there has to be agreement of all parties, or there has to be some external authority which can initiate functions controlled by these higher level contracts. So similarly, if you have some sort of change of algorithm on the blockchain, or change of cryptography which controls some secret data or so on, you should be able to make transition into a new system. So the conditions for transitions and how the transition will be governed has to be designed in advance. So you have to design design the change. So there are either kind of how a group can change cryptography later. How can you update the keys, etc. So there's some algorithms for proactive changes of keys. So proactive cryptography. This is kind of relatively new area, and another is governance algorithms, which are much more flexible, where you have some voting how to introduce new rules in the system. So here the rules are fixed, but some data, say keys or so on, or users or owners of the keys, or some parameters change. So here basic parameters change algorithmically. And here you have algorithms of governance which say how you vote for introducing new rules, and these new rules are maybe given within the same framework to some extent, and maybe the framework can change to some extent. So you're basically bringing new rules. That means maybe you are adding changes to computer programs which are used here, and you are voting for that, and then all the users will change, all the nodes in a distributed network which controls, say, a blockchain, will change the algorithm, how they mutually communicate. They will change some parts of this algorithm. And the governance mechanism has to say under which conditions that happens, how do we vote for that, how do we make changes, what is the format of the change. You have like a court procedure. Somebody makes a motion, somebody says, this is a problem and this is my suggestion, and you put it on the voting, you put it on the inspection. There are some steps, maybe somebody finds a mistake, and then even if it's minority, the incorrect code has to be maybe re-examined or something like that. So you can have a very complicated procedure of complaining, adding, choosing new representatives, choosing new algorithms, and so on. So you see, when we talk about blockchain, then there are different kinds of governance we can talk. We can talk of usual governance in real world governance. You can have a usual political governance. Say you have a community, and community organization, and community has its own body, and this body now uses blockchain as a technical means which will help making governance more transparent or more automatic. Say, for example, you want to make decisions on a daily basis. Say there is a crisis. So, say, for example, in a crisis, you need you make quick decisions, and say all the people who are controlling certain organization or certain project or whatever, all of them have their votes, and now they do certain kind of recording their emotions on the blockchain, maybe in encrypted form or something, and then there is some computer program which will add up all of this and make some decisions, or make transparent what happened as a result of voting, as a result of motion, as a result of political exchange, and so on. So this is a usage of blockchain for a usual governance. Then there is governance of blockchain, or of smart contract, or of distributed autonomous organization, which is one sort of a smart contract, which basically represents the mutual DAO is is like a smart contract which between many parties, which basically sets up relationships between the parties, which is such that effectively their relations are some sort of we do together a contract, we do some project together, and we have some financial interest. It is like making a company which is a company which is not registered in some office, but we simply say, aha, you are doing this, I'm doing this, I'm doing this, these are our relations. Something is happening automatically, some transactions, and then we basically function as one organization, as one public organization or one financial organization or whatever. And so you can govern these things. And also third, it can be some sort of, some sort of a mixed situation. There are some new kinds of online communities which are kind of new social realities. We have certain, say, you have certain art community, etc., and then they want to have their own governance, and they want to use blockchain as kind of backbone of some sort of a part of the background of the system. And they want to use it on the daily basis. It's not just some political moves. They use it for various things, and they have some reputation, they have some voting, etc. And combination of these are part of the realities of these online communities. So in a way, this is kind of containing blockchain inside, so it's part of like a two. But in the sense, it is like just a community. It's like a usual political organization. So in a way, it is kind of a mixture. But basically, there are two types of governance. Not this third is more or less first or second. Depends on the case. But it can be also viewed as a mixed case. So this is the governance. And you see, in any of these situations, and also on smart contracting platforms, important thing is that the stakes of parties in the system are not only stakes in various crypto assets and similar things which have only limited application domain, but also that you have some identity that you can be prosecuted in the real world, for example, if you do something wrong, or that your bank account can be seized if you make a big damage, or you did not pay something, or etc. So typically, classical public blockchain means you are nobody. You are completely without real world identity when you come to the blockchain. But once there are some sort of a primary kind of objects on the primary agents on the blockchain, say government has its representative, or etc. You have some objects whom you trust, and they have account on the blockchain, and they can something say about you. Then they can certify part of your identity. Then with your identity, you can have more weight on the blockchain. For example, you can put as a stake a handle of of the data which is kept somewhere in the government and so on your assets which are off-chain, and say trade them on the blockchain under certain algorithms which will allow such things. So who is certifying that you have certain assets off chain and that you can really sell them on the blockchain? Of course, with cryptocurrency, the basic advantage of cryptocurrency is that there is no double spending problem. Double spending problem is that if you online give just a copy of some certificate that you have some amount of money or something like that, and you transfer this asset somehow, that somebody can copy this and somewhere else spend that. So you have to either check in single database whether this has been spent or not. So this is kind of centralized approach. Or on the blockchain, you see, if you have a cryptocurrency, then every item has to be there has to be a record of transaction, and if you look at all the past, you can always check if the you can check whether the token has been spent or not. So this is one of the basic features of cryptocurrency, that it solves the problem with double spending, because you have all the past on the blockchain. You keep the record of all the past, and simply you cannot make a transaction in the same block. If you make a transaction, transactions in a certain order, and if some amount has been taken from some account, then this is seen. You cannot take it again because now the amount is smaller if you take it. So there is a list of transactions, and these transactions are in certain order. So you cannot, from the same account, if you are making two transactions, they will be in certain order. And if the amount has been spent, it cannot be spent in the next transaction. But say if you have a representation of external, then there has to be some authority in saying, okay, government can say you can sell the houses on the blockchain, but it has to be that and that blockchain, because some other blockchain can have a record of the same asset, and if you are spending there, then you have double spending problem. So you see, you have some sort of centralization. Although you are talking about kind of distributed economy and so on, you have a centralization lurking behind the scenes. For sure, whenever you represent the data from outside, there is a problem with this. So really, the parties and even the items which you sell, say art items and so on, they have to have their own identity, and this identity has to be kept on a single blockchain. It is like a token, and this token is issued only at one place. So if you say, okay, all the diamonds will be kept, there will be tokens. Maybe these tokens can be. There are ways to do transactions on other blockchains, but there are certain exchange mechanisms, but still there is a place where there is a blockchain which keeps the data of the original token, and that place has to resolve the problem with the double spending. So it has to be done in a very similar way like cryptocurrencies are done, but it's much more general. I mean, you can have tokens which represent everything, and tokens which are not refundable, exchangeable for other things. Money. Cryptocurrency is like a money. You can exchange it for practically anything else. You can divide it and so on. But but you can have tokens of things which are not dividable, not refundable in other means, and so on. So there are many possibilities to represent the real stuff by symbolic stuff on the blockchain, and the identity and certificates are very central things in ensuring that this functions well.